Okay, here we go. So, we are going to have a couple language of the discipline words today in our input. Our first word is going to be function rule. So you're going to make your L/D, language of the discipline. The function rule. Function rule. It's an equation that describes a function. An equation that describes a function. Now we also call this a function machine. So we're going to draw a little function machine. It's going to have a little spout at the top. It's going to have a little neck. It's going to come out like a box. And this is what we call the function rule. Which means for every input, so if I input a number, and input's going to be our x, there is some sort of output. For every input, there's an output. Our input is also known as our domain, which is also known as the x on the coordinate, x comma y. And our output, also known as our range, is the y coordinate. So if I have a function and they give me what x could be, I have to come out with a y. There's an input. It's basically algebra. If you give me x, I can give you what the other part is. I can solve it and find a y. And then that'll be my coordinate, x comma y. Then we have what is called function notation, which is how you write a function. You use what we call f of x, so the function of whatever number it is, to give you an output. So my input is f of x, whatever that x is, and if I solve that in an equation, I'll get my output, which is y. So let me give you an example. If they tell me y equals 3x plus 4, writing that in function notation means f of x, so the function, equals 3x plus 4. So I'm just replacing y with f of x. When you have that, put your pencil in the air. Thank you, Daniel and Haley, Lyle, and Coyce, and Jared. So when you usually used to graph on a coordinate plane, you would be graphing the slope, and it'd give you y, what goes on the x and the y axis. As a function, you put in x, you get a y, and then those are your two coordinates to graph on your graph. Okay? So our next word is called an independent variable. Independent variable. And that basically is your input, your domain, your x. The independent variable, whatever variable you're putting into the equation, is going to be your input, your domain, or what's known as x. Bless you. When you have that, put your pencil up. So we can practically guess what a dependent variable might be. If we know that an independent variable is our input, our domain, our x, our dependent variable is our output, our range, or y. So when you get asked questions, they might not just say, oh, what's the input or what's the output? They might say, tell me what the dependent variable is. It's another name for y, or your output, or your range. Okay, so I'm going to model quite a few examples because there are different ways they can ask you this on your homework assignment tonight. And remember, your quiz on Friday is based off of what we did 2 nights ago for homework and what's for tonight's homework, okay? So example 1, please write down the directions. This question says to evaluate the function rule f of a, remember that could be any variable, it doesn't have to be f of x, is negative 3a plus 5. To find the range of the function for domain, which means x's, and then they give you the x's that they want you to solve for. They want us to solve for negative 3, 1, and 4. It may look a little difficult, but it'll be simple, I promise. So evaluate the function rule. So they gave us f of a equals negative 3a plus 5, and they're giving us the domains, which means the x's, negative 3, 1, and 4. Miss Graham, it looks so hard. How do you do it? It's easy. I'm going to write down the equation that they gave me. Go ahead and write down the equation on the far left of your paper because we're going to have to write down 3. Now, I take the first domain they give me and I plug it in. That's all you do. So I'm going to take that first domain, which is negative 3, and I'm going to plug it in. So now I know that f of negative 3 equals negative 3. I'm replacing a with negative 3 plus 5. So again, all I did was take that first domain and plug it into the equation. Simple. All you do now is solve. Negative 3 times negative 3 is a positive 9 plus 5. 9 plus 5 is 14. So that basically tells me when my x is negative 3, my y is 14. Does that make sense? So they give you the x, I plug it into the equation, and I get what y is. And then you do it for the next one. F of a equals negative 3a plus 5. Okay. The next number they give me is 1. So, the function for the domain 1, I'm going to plug it in. Negative 3 times 1 plus 5. So then I solve. Negative 3 times 1 is negative 3 plus 5. You solve it just like an algebra equation. Negative 3 plus 5 is a positive 2. So when my x is 1, my y is 2. So that's why they call it a function machine. That's why you drew that machine. You plug something in, it's going to give you the output. It's going to give you the y. And then I'm going to do my last one. f of a equals negative 3a plus 5. So the last domain that I'm plugging in is 4. So when f is 4, I'm going to get negative 3 times 4 plus 5. I'm using different colors so you can see where I plugged it in. So then I solve. Negative 3 times a positive 4 is negative 12 plus 5. Negative 12 plus 5, different sign, subtract. Keep the sign of the higher number, which is going to be a negative. 12 minus 5 is 7. So when x is 4, y is negative 7. So the question asks me to find the range. The question asks me right here, find the range. Is the range my x or my y? Range means y's. So my ending solution, I'm just going to make a solution set. I'm going to put it in order. I'm finding my y's. It asks me for the y's, these ones right here. So putting them in order, I have negative 7, 2, and 14. That's my answer. So in fancy words, they're asking you for the range. It's basically saying, here are the x's, plug them in, what are the y's? Does that make sense? Yes?
Yes.
Thank you. Once you have that all written down, you can put your pencil in the air. So functions aren't hard. It's algebra, but it's basically for graphing. So whatever you have in x, you're going to get a y. Okay? Here's example 2. This says to model each rule with a table of values and a graph. So they're going to give us an equation. We're going to make a chart, and then we're going to find the coordinates and graph. 3 parts. So let's look at what they give us. They give us, example A, y equals 3x minus 2. So the first thing they want us to do is make a table. Okay? So my table is going to have my x. It's going to have the equation in the middle, 3x minus 2. Does everyone see where I got that? Right here. 3x minus 2. And then I'm going to have my y. So I'm making a table. Miss Graham, they didn't give us x's. Yeah, that's going to happen. What do? You make your own x's. And let me tell you, I make my x's the same number every time. The easiest numbers you can make them. I pick the same 4 numbers. Every graph, I pick negative 1, I pick 0, I pick 1, and I pick 2. I suggest you pick those same numbers every single time. They're the easiest ones to do. So now I'm going to plug in my x into the equation to get my y. It's like the machine. I take the x, plug it into the machine, work out the problem, boom, shoot out a y. Okay? So I have 3. What is my x right here? Negative 1. So 3 times negative 1 minus 2. So again, right here where x is, I plugged in what x is in the equation. So 3 times negative 1 is negative 3 minus 2. What's negative 3 minus 2? Negative 5. So that's my y. Then I do it for the next one. 3. My x is 0 minus 2. Well, I know. Okay, I got my 0. 3 times 0 is 0. 0 minus 2 is negative 2. And I move down to the next one. Now do you see why I picked the easiest numbers? Yes. 3 times x, which right here tells me it's 1, minus 2. I'm just plugging in for x. 3 times 1 is 3 minus 2. 3 minus 2 is 1. Then my last one. 3 times x. My x is 2 minus 2. 3 times 2 is 6 minus 2. 6 minus 2 is 4. So next to that, please write step 1, make a table. And write step 2, solve the table. Which means we plugged in our x's to spit out our y's. The next step that we're going to do is we're going to write the coordinates down. Write coordinates, or x comma y. So let's go ahead and do that. Right below my graph, I'm going to list my coordinates. I have -1 is my x. My first one, my y is -5. My next one, my x is 0. My y is -2. Next one, my x is 1. My y is 1. And my last coordinate, my x is 2. And my y is 4. So you just take it from the column. X comma y. X comma y. X comma y. X comma y. So now, simple, simple, simple. Now we're just going to graph them. So now you need graph paper. Oh, I'm sorry. Make a table, solve the table, write coordinates. So the last part that I'm going to do, I found what the coordinates are. The second part of my question says to model with the table and graph. Okay, so I'm going to take those coordinates and we're going to graph them. So you're going to draw a graph. Now your graph only needs to go up to like 5. So I'm just going to keep drawing a line down. Just go ahead and draw your graph. Mine's not very neat right now, but yours will be. So on my graph, the first coordinates I see are -1, -5. So I'm going to start at the origin. -1, go over 1. -5, go down 5. 1, 2, 3, 4, 5. There's my first coordinate. My next one is 0, -2. 0 means I move nowhere on the x. -2 means I go 2 down on the y. 1, 2. There's my second one. My next coordinate says it's 1, 1. So +1, move to the right 1. Boom. +1, move up 1. Boom. There's my next one. And my last coordinate is 2, 4. So +2, 1, 2. +4, up 1, 2, 3, 4. And then I'm going to connect my notes. And I'm done. I graphed it. That's it. So make sure on your paper, please write step 4 is to graph. So please add to your steps that step 4 is to graph. How are we doing with that?
Good.
Good? Okay. Good, good, good. example B, they're going to give us h of x equals negative x squared plus 2. Same type of problem. You have to make a table and then graph. Okay? So I'm going to make my table x, and draw a line. The equation, negative x squared plus 2. Draw a line, and then my y. Now again, pick the same numbers for x every time. Negative 1, 0, 1, and 2. Pick the same numbers every time. So now I'm going to plug in my numbers into the equation so I can spit out my y. Okay? So I have negative. Now don't get confused. My number that goes in there is negative 1. 2 negatives make a positive. Positive 1 squared, which means 1 times 1, is 1. Plus 2. My answer is going to be negative 1 plus 2, which is negative 1. So, positive 1 squared is 1, but you have the negative sign out here, so it's still negative 1. Remember, order of operations, got to do exponents first. Okay, then my second one, I have negative 0 squared plus 2. Negative 0 squared is 0 plus 2. I'm going to get 2. 0 plus 2 is 2. Then I have negative, plug in my x, 1 squared plus 2. 1 times 1 is 1, but it has a negative sign, so that's negative 1 plus 2 again. So I'm going to have 1. Sorry, I don't mean to have a negative there. And then plug in my 2. Negative 2 squared plus 2. 2 times 2 is 4, because that's squared. The negative sign, so that's negative 4 plus 2. It's going to give me negative 2. So now I'm going to step 2, list my coordinates. So what do I got? I have negative 1, comma 1. I have 0, comma 2. I have 1, comma 1. And I have 2, comma negative 2. Those are my coordinates. So after I've made the table and written the coordinates, my last step is to graph. So I'm going to make a teeny weeny graph on this side. So on my graph, I have negative 1, comma 1. Negative 1 means move to the left 1. Positive 1 means move up 1. That's my first one. Second coordinate is 0, comma 2. Means I move 0 on the x-axis. I move up positive 2 on the y-axis. My next coordinate is 1, comma 1. Positive 1, positive 1. And my last coordinate is 2, comma negative 2. 2 on the x-axis, 1, 2. Down 2 on the y, 1, 2. Miss Graham, that's weird. How do I connect it? It just goes up and over. And that's my graph. Nice little curvature. Parabola looking. Pencil up when you got it. Cool. Okay. Next example is going to ask you to find the domain and range in addition to graphing. Example 3 is to graph each function, then find the domain and range. Graph each function, then find the domain and range. We're almost there, guys. Bear with me. So you'll get an equation, just like the last example, y equals 4x plus 2. So in order to graph, we need to make a table. So I have x, draw my line, the equation, 4x plus 2, draw my line, and my y. Tell the person next to you what 4 numbers you're going to pick. Perfect. -1, 0, 1, and 2. Cool. So I'm going to plug it in. 4 times -1 plus 2. Well, 4 times -1 is -4. -4 plus 2 is -2. Okay, then I do the next one. 4, plug in my x, 0, plus 2. 4 times 0 is 0. 0 plus 2 is 2. Then I have 4 times 1 plus 2. 4 times 1 is 4. 4 plus 2 is 6. I know you wish we had one less problem, but we still have one more. That's so funny. Alright, and then we have 4 times 2 plus 2. 4 times 2 is 8. 8 plus 2 is 10. Shh. I know the music is distracting outside. Okay, so let's write our coordinates down. Everyone tell me the first coordinate.
-1, -2.
Very good. Tell me the second coordinate.
0, 2.
Very good. Tell me the third coordinate. 1, 6. And tell me the last one. 2, 10. Very good. You're right. Okay, so let's graph on this side. Now, I suggest, if you don't want to make huge graphs, that you graph by 2's so that you do not have to make a big graph that goes all the way to 10. But that's just my suggestion. So, my first one, because remember I'm graphing by 2, so this would be like 2, 4, 6, 8, 10, 12, -2, -4, -6, -8, -10, -12. Just so you guys know that I'm graphing by 2's. Okay, so I have -1, -2. So that's halfway in between. -1, down, -2. Bloop, that's right there. I have 0, 2. 0, 2. Bloop, right there. I have 1, 6. 1, 2, 4, 6. Bloop, right there. And I have 2, 10. 2, 2, 4, 6, 8, 10. So once I have that, I get my ruler, I connect the dots, and that's my graph. Now the second part of the question asks us to find the domain and range. Now, when you have a linear line, okay, that goes diagonal, my domain is going to be all real numbers. It's going to pass through infinity. The line keeps going. It's going to pass through all numbers. My range is my y-span. My y-span, if it's linear and a diagonal, is going to go through all the y's on the coordinate. So my range is all real numbers. So again, there's a couple parts to the problem. Make a table. Find the coordinates. Graph it. What are my domain and what are my range? Okay. Letter B. Ooh, this is fun. F of x equals the absolute value of negative 2x. Absolute value. Those are fun. So go ahead and draw your graph, or your table, I mean, excuse me. What numbers am I going to pick? Oh, yeah, that's right. Negative 1, 0, 1, and 2. They're the easiest numbers to do. So if I'm going to plug this in, the absolute value of negative 2, my x is negative 1. So, inside the absolute value first, I'd have negative 2 times negative 1, which is a positive 2. The absolute value of 2 is 2. So that equals 2. That's my y. So this one, the absolute value of negative 2, I'm plugging in my x, which is 0. And we want to know what that equals. Well, negative 2 times 0 is 0. The absolute value of 0 is 0. That was easy. And then I have the absolute value of negative 2. My x is now 1. Negative 2 times 1 is negative 2. The absolute value of negative 2 is 2. That's my y. Remember, the space is from 0. And the last one I plug in, negative 2 times a positive 2, which is my x, inside the absolute value. Alright, so negative 2 times 2 is negative 4. The absolute value of negative 4 is 4. So 4. Okay, so let's list our coordinates. What's the first one, everybody? Negative 1, 2. Good. What's the second one? 0, 0. Very good. What's the third one? 1, 4. And everyone, what's the last one? Sorry. 1, 2. Sorry. And the last one is 2, 4. I was getting ahead of myself. So, we need to graph those coordinates. So draw your graph over here. My first one is negative 1, 2, which means to the left 1, up positive 2. 0, 0 is my next one, so I don't go anywhere there. 1, 2, positive 1, positive 2. And then 2, 4, positive 2, up 4. Miss Graham, what is it going to look like? Oh, it's just going to look like this. The last part of this problem is to identify what the domain and the range are. Domain. And what's our range? Remember, domain means the x's. Range is the y's, the outputs. So if we look at that, looking at the x-axis, okay, is this going to cover all of the x's? All of my horizontal? They're going to be all real numbers. Now, what about the range? That's what Elizabeth just said. Y. Y has to be greater than or equal to 0. Y has to be greater than or equal to 0. Y cannot be anything below. Cannot be anything there. Okay, last one. Last examples. Oh yeah, they ask you 4 different types of ways, so I have to show you every way. The directions say to find the domain of each relation. So that means we don't have to find the y's, they just want the x. Find the domain of each relation. Second part of the question, is it a function? So yes, a function, no, not. So, for example, I have y equals negative 2x plus 1. If I look at this equation, let's see. It'll be all real numbers if I can plug any number in. Let's see. Negative 2 times 0 plus 1. That'll work. That's going to be a number. Negative 2 times 1,000 plus 1. That is going to be a number. Is it going to work out to be a number every time? Am I always going to get a y? Yes. So all you have to do is write all real numbers. If I'm always going to get a y output, it's all real numbers. Now, if I were to plug this in a table, can it give me an x and a y?
Yes.
Is my y ever going to repeat? No. So yes, it's a function. That's it. Let's try letter B. Y equals 1 over x minus 5. Now, when you graph, can anything be divided by 0?
No.
No. So, that's interesting. That's not going to work. So, when I talk about my domain, if I plug in 5, will it be 1 over 0? Is that going to work?
No.
No. So, x cannot be 5. That's my domain. X cannot be 5. Because if I did 1 over 5 minus 5, which is 0, am I going to get a function? No. So x can't equal 5. You can't have 0 in the denominator. But it is a function. Because I could plug in maybe 6. I could plug in 10 and get a number. It just can't equal 5. Okay.